In this section, we are going to discuss the solid's flotation dependence on the solid's density compared to the liquid's density. In experiment 1, two solids of the same mass but different volumes were immersed in water. The result was that the wooden box or wooden cube floated on the surface. However, the rocky cube sank to the bottom of the container containing water. So when we say that both have the same mass, both have the same mass, which is 5 kilograms, but different volumes, as you can see, the volume here of the wooden cube, the space here of the wooden cube is greater than the space or the volume of the rocky cube. So according to the formula, density equal mass over volume. Having the same mass, the volume and the density are inversely proportional. So since the volume of the wooden cube is greater than that of the rocky one, however having the same mass, this means that the density of the wooden cube is less than that of the rocky one. So having different densities, the result was different. Wooden box of greater volume, which means less density, floated on the surface. In experiment 2, the two solids of the same volume now, but different masses. Different masses, as you can see, rocky one was composed of 10 kilograms, mass equal 10 kilograms, and the wooden one is 2 kilograms. So according to the formula, density equal mass over volume. For the same volume, the mass and the density are directly proportional. So here, since the mass of the rocky one is greater than that of the wooden, for the same volume, this means that the density of the rocky one is greater. That's why it sank down to the bottom. However, the density of the wooden box is less than it. So the result was wooden box of less mass, less density floated. Experiment 3, two solids of the different masses and volume but same material. Here we have two different cubes. They neither have the same volume nor the same mass, but they are made of the same material. This means that they have the same density. The result was that both wooden boxes float on the surface of the water. What can we conclude in this sense? We can conclude that the flotation due to the buoyant force of an object doesn't depend on its mass nor on its volume, but on the density of the solid object relative to the liquid. So these 1, 2, 3, and 4 slides were just an introduction to studying the three cases of an object in which, in the first case, an object may float, being totally immersed, like in figure A. 2, float with being partially immersed, like figure B. And 3, sink to the bottom. This means it's totally immersed.